list. A linked list is a sequence of data structure which are connected together by a link. A list is a collection of elements in a sequential order. A linked list is a set of nodes where each node has two fields. That is, one is data field, another one is link field. The data field store actual fields of information, and link field is used to point to the next node. Basically, the link field is nothing but address node only, right? Then the linked list is a sequence of links which contain items. Each link contains a connection to another link. Linked list is the second most used data structure after array. Right? The following are the important terms to understand the file concept. Concept of linked list is the field is link field, next field, and linked list field. The link field consists of each link of the linked list can store a data called an element. The next field, each link of a linked list contains a link to the next link is called a next. Then linked list, a linked list contains the connection link to the first link called a first. The next topic is linked list representation. So the figure shows that the linked list representation. One header node is there. The header node is linked to the another node. Then it will be linked to the another one node. Then null pointer. The linked list contains a link element called the first element. Each link carries a data field and a link field called next. Then each link is linked with its next link using its next link node. The last link carries a link as null to mark the end of the list. The type of linked list. The type of linked list are simply linked list, doubly linked list, and circular linked list. Then basic operation of linked list, insertion operation, deletion operation, display operation, search and delete operation. So here insertion operation is nothing but add an element at the beginning of the list. Deletion operation is nothing but delete an element at the beginning of the list. Display operation is nothing but display the complete list. Search operation is searches an element using the given key. Then the delete operation is nothing but delete an element using a given key, right? Then insertion operation, adding a new node in linked list is a more than one step activity. We shall learn this with diagram here. First, create a node using the same structure and find the location where it has to be inserted. So here we can using the header node, then the next node linked with the next node. Then we can insert a new node, right? So we can insert the new node is in between A and B, right? So imagine that we are inserting a node B, that is a new node between A, the left node, and C, the right node. So then the point B next to C. So here we are inserting the new node B is in between A and C. So we can insert the new node. We can write the code is new node dot next right node, right? So it should like this. We can insert the new node is here, right? We can insert the new node is here. So left node dot next is new node, right? Then header, the next node we can insert the new node for in between A and C, right? This will put the new node in the middle of the two. The new list should look like this. So here this first node is node is A, second node is B. We can insert the new node, that is B, and the next node is C. Similar steps should be taken if the node is being inserted at the beginning of the list. While inserting it at the end, the second last node of the list should point to the new node, and the new node will point to the null node, right? Then deletion operation. The deletion is also a more than one step process. We shall learn with pictorial representation first, and then locate the target node to be removed by using searching algorithm. So here this is the node, the left previous node of the target node now should point to the next node of the target node. So then we can like the C program, left node dot target node dot next. Then here the header node, the next node, then we can use the target of the next node. So the arrow mark will be move on to the target node to the next node. So this will be remove the link that was pointing to the target node. Now using the following code we will remove what the target node is pointing at. So suppose we can remove the node in middle node, right? So this is first one is A node, the second one is B and third one is C. So we can remove the node of B means we can simply remove this and join the link to the node A to C. So the B node will be removed. So target node dot next is null, right? So after removing deleting the node, the diagram is shown here. So the header node, the node, next node, then removing the target node and it will be connected to the first node and the last node, right? Then reverse operation. This operation is the operation is a throughout one. We need to make the last node to be pointed by the header node and reverse with whole linked list. So here this is the node. First we traverse the end of the list. It should be pointing to null. Now we shall make it point to its previous node, right? So this is a diagrammatic representation of reversing node. We have to make sure that the last node is not the last node. So we will have some temporary node. We will assign some temporary node which look like the header node pointing to the last node, right? Then we shall make all left side nodes pointing to their previous node one by one. So this is the diagrammatic representation of the reversing node. Except the node, that is the first node pointing by the header node, all nodes should point to their precedence node. So making them their new successor node. The first node will point to the null, right? Then we will make the header node point to the new first node by using the temporary node. So this is the diagrammatic representation of reversing a linked list, right? The arrow will be marked by the reverse order. Then doubly linked list. Doubly linked list is the variation of linked list in which navigation is possible in both ways, either forward or backward. Backward easily as compared to singly linked list. Following are the important terms to understand the concept of doubly linked list are the same concept, link, next. Here we can additionally we can add the previous, right? Then linked list. Link is nothing but each link of the linked list can store the data called the element, and the next node is linked to the next node called the next. At previous, each link of the linked list contain a link to the previous link called the previous. Then linked list contain the connection link to the first link called the first and the last link called the last. So this is the double linked list representation. Here the same as the header node and three nodes are represented. So here both arrow marks are both forward and backward directions, linked by forward and backward directions. So this is the representation of doubly linked list. So the following figure, the few important points to be considered. First one is doubly linked list contain a linked element called first and last. Each link carries a data field and two link field called next and previous. Each link is linked with its next link using the next link. Each link is linked with its previous link using its previous link. The last link carries a link as null to mark the end of the list. So the basic operation: insertion, deletion, insert last, delete last, insert after, delete, display forward and display backward. So insertion, add an element at the beginning of the list. Deletion is delete an element from the beginning of the list. Insert last means we can insert the element at the last. Delete last means we can delete any one of the element at the last. Insert after means add an element after an item of the list. Delete means delete an element from the list using the key. Then display forward means to complete list in a forward manner. Backward approach is nothing but display the complete list in a backward manner. So this is the diagram for singly linked list. Singly linked list is the next list. The next pointer of the last node point to the first node is a singly linked list. Doubly linked list is nothing but the next pointer of the last node point to the first node, and the previous pointer of the first node point to the last node, make the circular in both directions. So this is the doubly linked list or circular linked list, right? So here the basic operation, the same operations we are using here: insert, delete and display. So the symbol diagram, symbol C representation of insertion operation is: insert first data, begin, create a new node, data. Then if the list is empty, then the header node is added. Then the next node of head, else we can assign the temporary node to head, while next of temporary is not head. Do temporary is equal to next of temporary node, done. The next of node is equal to head, next of temporary is equal to node, then head is equal to node, end if end. So this is the representation of insertion as well as deletion and display operation. Thank you.